Welcome and hello. This is a video tutorial on HEC HMS, and in this lesson, I'm going to discuss reservoir routing, specifically the specified release routing for reservoirs in HMS. All right, what I have on the screen here is my HMS version 4.12, and I have a very simple watershed schematic sketched onto the basin model right here. So I have a sub-basin and then a reach, and then downstream of that, it flows into a reservoir, and then another reach, and then that flows into a sink. So up here in the Watershed Explorer in the top left, I have those same hydrologic elements listed here in hydrologic order. Okay, I'm going to go ahead and select the reservoir element because that's what we're talking about here. And then down below in the components editor, we have the different parameters that are assigned to our reservoir one. They include the description, that's optional. The downstream reach is this reach here, reach 2. And then after that, we have our method. So this is the reservoir routing method. Options are shown here: none, outflow curve, specified release, outflow structures, and rule-based operations. So a specified release will be the routing method we discuss in this lesson. So let's go ahead and click that. The specified release routing method is designed to model reservoirs where the total reservoir release is known for each interval of the simulation. Therefore, the total storage is always known based on the beginning storage, the inflow, and the outflow for each time interval of the simulation. The first parameter that we need to define after specifying the specified release method is whether we're going to use a storage method based on elevation storage or elevation area. So based on what we select here, it will affect what sort of paired data set we need to provide HMS in the next field down. So if I select elevation storage, then I need to provide an elevation storage paired data set. Now, right now, I don't have any defined in my program, so let's go ahead and do that. I'll go up to Components and then Paired Data Manager. And then for the type, I'm going to select Elevation Storage Functions. Now, let me just point out the next option down is Elevation Area Functions, so that's the one I would select if I selected Elevation Area here. Okay, but I didn't. So Paired Data Manager, and then Elevation Storage Functions, New. I'll give it a name. I'll just call it Elevation Storage Reservoir 1 and create. Okay, so let me close that. Now I have an option to select the elevation storage for Reservoir 1. Now, I don't have any data yet assigned to this. It's just a sort of an empty data set and it's been assigned. So if I went up to the paired data manager and then expanded the elevation storage functions, here is my paired data set. My data sources are manual entry or DSS file. If I select manual entry, then I can go ahead and enter data in here for the elevation and the storage. So what you're really just doing is starting at the invert of the reservoir, the very bottom elevation, and then as the elevation increases, so will that storage. So just keep in mind the units are 8 feet, an acre feet here, and this defines the geometry of the reservoir. Once some values are typed in here or pasted in, you can paste in values from Excel if you copy them to your clipboard. Then you can click this graph button and it would kind of show you what the curve looks like. All right, if you happen to choose DSS file for your entry, then that's fine too. You just have to specify a file name and path name. All right, let's go back to the reservoir. So I'll click the reservoir and then select that elevation storage reservoir. One thing to point out though is if you select elevation area, it doesn't update this next field down here. Elevation storage is still selected. I've just noticed this when kind of preparing for this lesson. So go ahead and click the save button and then it updates. Yeah, now it's expecting you to select a elevation area paired data set. So let me just change that back and then save. And then, okay, that's what I want. The next field down is the initial conditions. So if I have elevation storage selected as my storage method, then my options for initial conditions is elevation or storage. Now, the initial conditions it really cares about is the storage as far as mass balance goes. So if you select storage, you just type in your storage, say 50,000 acre feet. But if you select elevation and then you type in an elevation, say 500 feet, then it will use that elevation storage curve provided and calculate the storage based on the provided elevation. One other thing to point out though is if you select a storage method that's elevation area, then your only option here is elevation. And I'm still seeing storage as an option. So hold on, let me just click save. Maybe that will fix it. So elevation area. Yeah. Okay, so now elevation is my only option for the initial conditions if elevation area is selected as my storage method. All right, let me go back. This should allow me to click storage, select storage though. You know what? I'm done with that. Let's move on. Next is a discharge gauge. This is basically defining the release from the reservoir at each time step of the simulation. So what we've done already is define the reservoir geometry, define the initial conditions, the initial storage of the water in the reservoir at the beginning of the simulation. And now the discharge gauge is going to dictate the actual specified release, that's the name of this method, to for each time step of the simulation from the reservoir down into this downstream reach. So what it's looking for here is it's not a pair data manager, it's a time series data set. So you can tell by the icon what sort of data it's looking for. But I don't have any time series data set yet for discharge gauges. So let's go ahead and do a quick example of that. Components, menu, and then time series data manager. For the data type, I'm going to select discharge gauges and then click new. We'll give it a name. I'll call this discharge reservoir 1 and then create. Okay. Up here in the time series data, I have discharge gauges. And if I expand that, I have a discharge for reservoir 1. So I have an optional description. My data source is manual entry or DSS file or multiple DSS files. Next down is my units. I'm going to actually set it to US customary units, and then time interval, and then a few optional fields. So for manual entry, if I wanted to type in the actual releases for every 15 minutes, I would need to create a time window, it's called. So I'd come up here to the time series data set, right click, create time window. And now I need to specify the start date time and the end date time of that time window. If you're curious more about these time series data sets, I have created a separate lesson earlier in this playlist. It is lesson 3. It's titled Time Series Data. So go ahead and check that out. What you're seeing here is just sort of an abbreviated version of what you'll find in that video. What I'm doing here is I'm just pasting in some start and end date time. It's going to be for the first month of 2024. So I'll click add and then close. Now, if I expand this little plus button besides this time series data set, I now have a time series window. And it gave me a window also for the first day of the year, but I just want the first month. So I haven't quite figured out why that's happening. I'm going to go ahead and click delete. All right, so this is a 15-minute time step for every 15 minutes of the first month of 2024. And then, so here's the data down here. This is the time window tab. And then if I click on table, now I've actually pasted in some data over here. I'm not sure why it's saved, but what you'll probably see is a bunch of empty values, and then you can type in values or paste in values. I pasted in values preparing for this lesson, and here they are. So go ahead and paste in your numbers or type them in, and then you can click this graph button tab, this graph tab to see the data. So what I have right here is very simple. It's just releases ranging from 500 CFS up to 550 over the course of the month. One more thing to mention is if you have missing data in your data set, then the simulation will halt. It will not complete the compute. Unless you have in your basin model, you go ahead and have a replace missing values set to yes. That would take care of that problem, but I prefer just set it to no and then make sure that my time series data set does not have any missing values. So just taking a little extra effort to do some pre-processing on my input data could go a long way to preventing headaches down the road. All right, so let me go ahead and select the reservoir. Select that discharge reservoir 1 for my time series data set. Again, that's those values that range between 500 and 550 CFS every 15 minutes. And the last two fields here is max release and max capacity. Now, I'm seeing a little red asterisk by the label. However, the user's manual mentions that these are optional fields. I'm going to go ahead and type in some numbers. We'll say the max release is 50,000 CFS, and then the max capacity of the reservoir is 100,000 acre feet. If these values are exceeded, for instance, if the discharge exceeds 50,000 CFS or the reservoir storage exceeds 100,000 acre feet, the simulation will continue, but the user will receive a warning notifying them of this violation. So, of course, the release would be dictated by that discharge gauge, and then the capacity itself will be calculated at each time step based on the previous time step's capacity or volume of water in the reservoir, plus the inflow minus the outflow for each time step. So it's just mass balance. All right, well, that's all I had prepared for this lesson. We talked about the specified release routing method for reservoirs in HEC HMS.